John here. Today I'm going to show you how to create a new library and start putting your own symbols in it. I want to build a breakout board for this processor in a 48-pin package. This thing comes in two options. Let me see if I can find it. There we go. It has a 48-pin version here and a 64-pin version there. I've done the 64-pin option for another project and I have created that symbol, but I don't yet have one for this particular part. So let's go ahead and figure out how to do that. So if we want to start at the beginning, we need to create a new library. So open up KiCad. Now for some reason I can't use the library and footprint editor unless I've got a project open. I don't know why that's relevant, especially if I want to edit the global libraries that are not really affiliated with a specific project. But let's go ahead and create one anyway. It's no big deal. 2046 test. And let's make a new one. So there's nothing hiding under the covers or behind the curtains there. Okay, so what do? We're going to go hit this guy. We're going to open up the symbol library editor. And now we want to think about this for a few minutes. I'm going to create a symbol library, but eventually I'm also going to need to create footprint libraries and things like that. So where does this go? Let's take a little bit of a cue from what GitHub, or rather what DigiKey did. Remember when we created this library and I cloned the DigiKey KiCad library? I'm going to go ahead and make a directory next to that one for mine. And in here, what I did is I based my license and README file off the ones that DigiKey used. You should read them. They're actually pretty reasonable. It's Creative Commons, but they relieve one of the clauses so that you don't have to say that your design used DigiKey footprints and so on. It's more friendly and makes sense for engineering kind of projects. So I went ahead and used it for myself as well. All right, so what do? First thing, we have to have a library to put our symbols in. The way these things work is one, it turns out to be a pair of files, is going to be created. One of them is an index and the other one has all the symbol data in it for our library. So what we want to do is we want to create a new library right here. And we want to name it, and we want to tell it where to put it. I don't want to put it in the middle of my project. I want to make this a library that I'm going to use in multiple projects, and I want to put it in my new KiCad library thingy. So this is a symbol library. So let's call it the JB symbol library. Okay? And that's all we need to do to create a new library. Now it's going to ask you, look, which symbol library table do you want to put this in? I'm going to choose global because I want to make it available for all my projects. Now what does that really mean? What that really means is you don't have to then go over here. Remember when we brought in the DigiKey library, or if you go take my library, which I'll share on GitHub, if you want to bring that into your project, you remember you have to put it in this table. This is of all the global libraries. See all the DigiKeys from before? It automatically put mine in for me, okay? That's why it will now work automatically. Otherwise, you'd have to do that by hand. So once you've got yourself a library, first thing I guess you can find it over here. I'm right there. There's no arrow. If there's an arrow, you can see these are all the parts in this library. Mine doesn't have any parts yet. It's an empty library. So let's put one in there, create a new symbol. Oh, that's not what I want to do. That is not what you want to do. You want to hit right-click on this library and create the new symbol this way. I forgot about that. You can do it the other way, but that involves other things. This one's much simpler, straightforward. Okay, what do I really want to do? Remember, there's two different kinds of these chips. I'm going to name it this. I made this mistake once before, and I named this part only by using this as its descriptor, which is a terrible choice because I don't know which one it is if you only look at its name. So that foolishness has to stop. This new one I'm going to call the right name that I should have done in the first place. It is a designator U because integrated circuits have like a U. You know, it was a resistor, I'd use an R, and a C is a capacitor. You're familiar with all that sort of stuff. The rest of these fields I'm going to use the defaults on. These are more advanced features of complicated parts that have more than one subcomponent within them and things like that. Or am I going to create a symbol that's really represents power? Do I want it to show up? Remember, there's a power symbol icon and a regular symbol icon in the schematic editor. Should it be in the other one, and so on? No, this is all generic stuff. It's an integrated circuit. So I'm going to hit OK. You can look over here. You can now see the symbol library itself has been modified, and this part's been modified by the mere fact that it was created. I'm going to Control S to save it. And it's a pretty lame symbol right now. It doesn't have any pins. I'm going to move these things up and out of the way because I'm going to put all the pins and the drawings and stuff in the middle of this right here, okay? So what am I going to do? The first thing I want to do is make sure that my grid makes sense. I don't like the 50 mils. I prefer 100 mils for my symbols. Not, whatever. A lot of the KiCad symbols are on 50s. I prefer the 100s. That's a personal preference. You do as you wish. Okay, so here we go. There's the 64 pin chip, and here's the 48 pin version. This is the one that I want to be creating. I'm going to leave this drawing over here to the side for reference. Make this like this. I'm going to just copy it as we go. Alright, so let me get both of these on the screen. There we go. That looks pretty good. Now what are we doing here? We're using basically the same thing as the schematic editor, but instead of putting symbols, we're going to put these pins, or what I like to call terminals, because it's this little round thing and the pin number that are the important and critical things. Most of these we can just use the defaults. I prefer the length to be 2/10 of an inch. We're in inch mode over here, so these are all in inches. This is what the length is of most of the pins on the parts in the KiCad library. I don't know why it showed up as 1/10 by default, but that's fine. You can put whatever you want in there. It should be a multiple of 0.05 inches, otherwise the snap to grid in the schematic editor will upset most people. So 0.2 is pretty reasonable. That's what, like I said, most of them use. All right, so then you just go around the horn and create your pins. The pins can be placed with the terminal bulb, this little bubble on the left or the right. I don't know why they chose these names. I guess right to them means that the chip body, the picture, the description of the pin will be on the right. And they can go up and down like so. And what I'm going to do is I'm going to draw this chip the same way you see it here. So I'm going to have pins that go out this way and down and over this way and up like that and so on as they go around. For each pin, you have to choose an electrical type. For most of the pins on this chip can be programmed to do just about anything. This electrical type is used by the design rule checker. So for example, I'm going to make the pins that have power, I'm going to call these power inputs. That way, if I forget to hook one up and I run a design rule check, it'll say, hey, you forgot to hook this power input up. On the other hand, these other pins over here don't necessarily need to be connected because of the nature of this particular part. The ones that have this programmable functionality, I'm going to just say, look, these are passive. And once you declare a pin as passive, the design rule check pretty much doesn't tell you anything at all other than is it connected or not, which is useful in its own right. So I'm going to have passive pins and I'm going to have electrical inputs. This reset pin, turns out this is an input pin. So I'm going to actually go ahead and declare it as an input. Okay, like this. When I create this pin, I'm going to make its type be input because it has no other role. But most of the other ones, like I said, are going to be passive. So I'm going to just set this up and start going. All you need to do is you put a name in like this and the pin number. So that's pin 1. The only thing that means anything at all, keep this in mind, to the schematic editor and your net lists and everything else, is the pin number. This name is only for human consumption. That's it. The design rule check uses the electrical type in addition to the number, but everything else is just drawing and visual to help the designer understand what they're going to do. So I'm going to make me some room here, I guess, and just go around and cut and paste these names out of the PDF. That's pin 2. And I'm going to try and be very careful about what I'm doing here, because if I do this wrong and then I design a schematic and I don't refer back to here to check my work, then I might end up making PC boards and paying money for something that doesn't work. This is very difficult to do while speaking. Okay, so now we want to make sure that the terminal is on the bottom. And I can't cut and paste on my PDF anymore, so I have to type these in all perfectly now. Oops, and you can see I made a mistake right here. This is PIO13 and it's on pin 13. So you can just go back and hit E, just like you can in the schematic editor, and edit your your parts if you make a mistake. No big deal. And again, back to the electrical type for power input. Now, a special thing for reset, if you want to put the bar over it, you put a tilde before and after the description like that. And you can see in the preview down here that there's a bar on top of it. And again, the pin number. Now, remember, that is an input. It's a dedicated pin. Oop, that's not a power input. It's an input right there. Again, this is going to be used by the design rule checker. So there you have basically all your terminals. I'm going to hit Control S to save it now. Now, I can do a quick, simple sanity check of this thing. We know we have the same number of pins on each of the four sides. So if I kind of grab if I'm in the pointer mode and I just kind of do a select and draw this box like this, I can clearly see the same number of pins are on the left and the right. Oops, I don't want to move anything, so I'll hit escape. And then I can draw another box like this across the top and the ones on the bottom. There, turns out they're all the same number of pins, but they don't line up, so that might look funky if I let it be that way. So I'm going to go ahead and move this over one to make it look symmetric. No, it looks like these guys are too far to the right. So, I mean, this is all just cosmetic at this point. So I'll hit Control S to save that again. This looks pretty good. Now, you'd be a fool not to double check your work here, because this will just propagate itself into your project or multiple projects as you move forward. You really need to make sure this is right. So one of the things I'll do right now is go through in my head and count 1, 2, 3, 4, 5, 6, 7, 8. And find out that there are exactly 48 pins. They're all numbered, they're all in order, and they go around like this. That looks good. You look over here, you see all these are PIO 0 something, and you got a DP and a DM on the pins 5 and 6. Okay, and then you got more zeros and you got 3 1s down here. So I'm looking at all zeros. I got the P and the M. I got more zeros and 3 1s, an O and a 1 and a 2 down here. That all looks good. Across the bottom, I got 3 of these that are PIO 1s. That looks good. 3, 4, and a 5. An SSA, a DDA, a DDSS, and these are the pins after 19, 20. 3 1s and 2 zeros over here. 3 1s and 2 zeros. That looks good. Real-time clock in and out. Let's see where am I. And what do we got? PIO 0, 4 to 13. PIO 04 to 13. That looks good. And up on the top, I got PIO 0, 14, 15, 16, 17, 14, 15, 16, 17. Now, I don't actually have to use the same names that they did here. This is the debugging I/O system. I don't care. I don't actually use it on this chip anyway because it has a USB programmer built into itself. So I'm looking at PIO 0, 18 to 21, 22, and reset on 40. I can't believe I did all these right on the first try. That just means I haven't figured out what's wrong with it yet. So beware. All right, now we want to put the yellow block so that it looks like all the other integrated circuit designs. That looks like the upper left corner up there. I'm going to click once with my left mouse. Click once here with the left mouse, and you're done. I'm going to hit escape. Now I'm going to have to click to select it, and then I can hit E, and I'm going to say fill the background. That makes it yellow. Control S to save, and now we're in business. It turns out that no matter where you put these, it seems that the schematic editor puts them in a random spot anyway. So I'll put it off to the side here, but I don't know. Maybe one of you knows and can help me figure out why my parts always have these things show up in weird spots by default. Now I can see this thing is a little bit lopsided. I don't like the way that looks right now, so I'm going to grab these pins. I'm going to move them one notch to the left, and I want to grab this rectangle. I should be able to grab it and move it. If I can hit M, maybe. I don't know if it's going to move the whole thing yet. Well, I can just delete it. Hit delete and redraw it. No big deal. All right, that looks better, I think. left click, escape, click to select, E to edit, fill background. Now it looks like it's more symmetric. It's not exactly centered. This crosshair is going to be when I'm in the schematic editor and it shows up and I move it around, I'll be holding it down here versus more near the middle. That doesn't really matter, but I might as well at least try. That's not quite middle either. It turns out with the grid set this way, I can't do it exact. Because the exact middle would be between pins 6 and 7 here, for example. But this is much better to close and centered. So I just hit Control-S, and it's all saved. Everything's good, and we're done. You've now created a symbol. You put it in your library. You could use it like this, but there's some niceties you'd probably want to do, like in your properties. There should be a description that says what the darn thing is, and it is implied by the name. But when you open up the symbol selection tool, the editor thing, it would be nice for you to tell the person that this is a 51U68 48 pin LQFP. That's the version of this thing. These aliases are like, let's say, like in a previous video, you had these like D-sub connectors, like a 9-pin D-sub. It's commonly known as a DB9, so you would give it an alias. If you call it a D-sub 9, give it an alias of a DB9, because somebody might try to be putting that in as a name and then not even find it and get all frustrated. That's what the aliases are for. Footprint filter, I've never used these. I believe what they're for is you could say something like, this is a resistor or something like that. And then when you're in the schematic editor and it says, hey, I want to find a footprint for this part, it can narrow it down and know that it's a resistor. In this case, that is not relevant, because I'm going to do something else. And I'm going to put in, by default, I'm going to give it a footprint, which is not normally what you do in KiCad. The KiCad libraries that you get from KiCad don't have these. But this part is incredibly specific. It's from one and only one manufacturer, and this particular one is only available in one and only one footprint, so why make the user type it in and go find it every stinking time? Just go in here, just like you would in the schematic editor, find the one, and set it. And this is right here. It's a QFP package. It is a 7x7 48-pin half millimeter pitch. That's the footprint right there. You don't know what the footprint is? Go to the bottom of your data sheet and it'll give you instructions if you have to design the footprint, the copper foils. That's what this picture's for. And there's the 64-pin version and the 48-pin version. There's the 40, what is this? This is the 64 lead version in the measurement, so that's a 10x10. The 1.4 here means that's how thick and tall it is. This is going to be the 48-pin version. Oh, this is funny. There's a nice typo in this PDF. It's a Prola Quadat package. You'd hope that there aren't too many other typos in this PDF. Don't do me any favors, guys. So this is a 7x7 millimeter, and it's 1.4 millimeters thick, okay? But for the footprint, what we care about are these other measurements. You want this capital E dimension here, capital D dimension there, and this little e right there. If you look at big D and big E, they give you an over-under. So this really is a 7x7 by 0.5 millimeters, okay? And it should say all dimensions are in millimeters right there. Okay, so that's what this is talking about here. 7x7, 0.5 millimeter. Double click like you do in the schematic. You can put the datasheet link in here as well and link this over to the NXP website and hope that they don't move the files around. I generally don't put those links in because by the time years go by, the things don't work anymore anyway. To me, it's more important to have the DigiKey order number in there so I can buy it. And once you're at DigiKey, you can get the spec sheets from them anyway. They keep all that up to date. So I'm going to hit Control-S now that I've put all that fun stuff in there. If we then go back over here and we say edit my schematic, I don't care about the title block or anything. I'm going to just throw it on apart and play around. I type in LPC 51U68. We can find, here's the super coolly groovy new one in the 48-pin package, and a little description. And here's the one that I put in there before, poorly named. but it's the 68-pin version that I made for another project long ago and put in my little JW library. Here's the better version. I should probably delete the old one and recreate it in my new library someday. Okay, there we go. And it looks fine and dandy. Let me hit escape and move these to a decent spot. Like I said, this thing always seems to want to put them in random places. If you know how to fix that, let me know. I look forward to your comments. I don't know, what do you want to do? Let's hook up some pins and do something foolish, like hook these together, and maybe I'll short out the power pins and then run it around over here. Woo! And short them to these guys down here. Like that. And I do this for a purpose. Okay, so save this. Escape. Let's create a net list. Don't design rule check. It'll get a million errors because this is just foolishness. We're going to save it in the default place. We forgot to annotate it. The one and only one part needs to be given a number. That's why U1 is in there. And because it modified it, I got to save it again. All right, so we have a little schematic with one part in it. If we open up the PC board, what do we want to do? Read in the net list. First time doesn't really matter. You can see the little thing showed up right there. It's all green. Close, put it down somewhere. Have a look-see, and you can see the air wires make sense based on the drawing that I just did. I connected these two down here, and I connected something over there, and you can obviously start laying out your design. I guess the grid on here is a little coarse, but that's fine for playing around. What do we want to do? Maybe we can run a wire over here. And now we've made ourselves a board, a circuit diagram, and a PC board with our new part. Let's do Alt-3. We can even look at it. And because we use a part that's in the KiCad library already, it even has the 3D footprint for it and everything in there, and the Pin 1 designator. Look at that. Absolutely fantastic. So there we go. Custom symbol in your own personal private library. And I'll probably push this out to GitHub so that should you need this part, the 1 in a billion chance, at least you can use mine and not type this one in all on your own. So if you thought this was useful, let me know in the comments. Give me a thumbs up or whatever. Thanks a lot for watching. I'll see you next time. Bye.